Hello and welcome. Thank you for joining us today on a case study of how we ported Minecraft Realms from AWS to Azure. Here's a quick overview of what we're going to be discussing today. We'll do a quick introduction of myself and my colleague. We'll touch briefly on what is Minecraft Realms, and then we'll go through the three major parts of the migration process. So, who are we? I'm Brian Trevathan. I'm a senior software engineer. I currently work for the PlayFab organization, and I've had the good fortune of being a member of Team Xbox for about 14 years now.
Hi, I'm Mangal Srinivasamurthy. I'm a software engineer at the Minecraft Realms team. I've been a member of Team Xbox for about 7 years now.
Wonderful, thank you. So what is Minecraft Realms? Realms are Minecraft servers that are run in the cloud and managed entirely by Mojang. The Realms service was built by Mojang prior to being acquired by Microsoft and thus was built entirely on top of AWS. Eventually, the decision was made to move the service to Azure, and that is where we got involved. So the Realms service consists of two big pieces. We have service logic that we use to start and stop and configure game servers, and this is your typical HTTP request handling code. Additionally, we have code to manage the machines that are hosting the actual game servers themselves. So the first step in our migration process was to migrate the logic for managing those machines that are hosting the game servers. And we call that migrating game server hosting. So I actually like to do this by telling you a story about doing one of the most enjoyable things in all of software development. And it all starts early in my career when I had a mentor who told me, he said, some of the best code you'll ever write is with the delete key. Deleting code is a magical feeling. The more code you delete, the less code you have to maintain. And infrastructure code is some of the best to delete. It's super important, but is almost entirely invisible to your users. No one notices that it's there until something goes wrong. So shifting responsibility for infrastructure to another team frees you up to go write really cool features for your game. So what follows is the story of our journey. So what did we delete? You can see on the left where we started. You can see that we had both service code and game server code hosted entirely in AWS. Clients communicate with front ends to manage their realm. This includes things like changing the name of the realm, setting the difficulty, updating the list of players that are allowed to play, etc. When a player wishes to join a game, the front end would reserve a game server from a pool and return its IP address and port back to the client. Additionally, there were job agents constantly running and watching the state of that pool. They would allocate more VMs as load increased and destroy VMs when they were no longer needed. Lastly, there was custom code authored by the Realms team that was running on each VM that we called the agent. It started and stopped the Docker containers that containing our game server and relayed messages from the front ends into those containers. So on the left, you can see where we ended. Now, this is not the final state we're in today. This is just the state after we finished the game server hosting migration. We can see that game clients still interact with front ends in AWS, but now those front ends are using the PlayFab multiplayer servers APIs to reserve a game server from the pool. And now PlayFab multiplayer servers is the one doing the hard work to maintain that pool of game servers for us. It's scaling the number of VMs used to host our game servers as needed. Now, when a player wishes to join a game, then our front end calls a simple API in PlayFab that requests one of those standing by game servers in that player's region, returns back the IP address and port just like before. The great thing is that this meant we no longer needed the agent running on the VM hosting the game servers. We were no longer relaying messages through that agent to the game server, which eliminated a source of failure for us. No more jobs to scale up and down that pool of VMs. No more monitors watching that code, and best of all, no more alerts waking us up at night when that code starts having problems. So we discovered that getting started with PlayFab multiplayer servers was actually pretty easy. All we did was take the game server development kit from PlayFab and integrate that right into our game server. We provide PlayFab with our game server executable. We tell PlayFab how many game servers we can run on a single VM, so how densely we can run. And then we tell PlayFab how many instances of our game server we want to have available and standing by in each region around the world. And that was it. So how did we do it? Step one was to migrate the actual game server hosting code itself from one cloud to the other. So we introduced a new abstraction. We wanted to be able to run on either the AWS cloud or the Azure cloud during this migration process. That way, if something was wrong with our Azure implementation, we could always fall back to our known good implementation on AWS. Now, the original code didn't already have an abstraction for handling game server hosting, so one had to be created. Then we had to go create 2 implementations of that abstraction. So this was a little odd. Even though our goal here is to delete a whole lot of code, this process actually required authoring a whole lot of new code. Now, fortunately, much of that new code, namely the AWS implementation of the abstraction, could later be deleted, but it felt a little bit like 2 steps forward, 1 step back. And also, it's worth mentioning that while all of this is conceptually quite simple and fits really nice and neatly on one slide, it actually represented a tremendous amount of work and didn't always work as we expected, which we'll actually touch on later. So the second step in our process was to create another abstraction for the game world's data storage as well. So migrating just the compute for our game sessions wasn't enough. Because the player's world is persistent, then every session on Realms requires that we retrieve the player's world data from storage and place it on the VM in Azure before the session starts up. Now, copying that data from S3 into Azure is naturally much slower than copying that data from within the same data center. And that additional time spent copying would increase the amount of time that players have to wait before they can start every game session. So leaving that data in S3 wasn't really an option. Therefore, we needed a way to move the player's world data into Azure as well. So we considered bulk copying the data, but that would have involved some amount of downtime since a player wouldn't be able to play their realm while their data was being copied. Plus, we would have had to have come up with some sort of new system for locking realms while they're migrating and unlocking them later, and that would have just been a whole new source of potential bugs. So ultimately, we decided to read existing world data from S3 and then write all updates to Azure Blob Storage. So essentially the way it works is that when the game session starts up, we look and say, is there data in Azure Blob? If the answer is no, then we'll go get that data from S3, bring it onto the VM, player plays their session, and when they're all done, we put it in Azure Blob. Then the next time that player comes to play, we'll say, is there data in Azure Blob? Yes, there is. Great, no more S3. And this basically meant that all active realms were sort of migrated automatically. Players did experience a small delay the very first time they played their realm on Azure, but it was a relatively small price to pay for an otherwise quite performant system. This also had the additional benefit of sort of spreading out the load for the data migration. Rather than having to scale up some solution to support copying all of the data at once, we instead spread that load out as players were playing their realm on Azure for the first time. And we sort of actively chose not to move over inactive worlds. We realized that this plan worked great for active realms, but realms that weren't getting played were going to stay on S3. And we accepted that as a limitation and felt like that was something we could come back and address later, which actually Mangal will speak to later in this presentation. So our third and final step was around tooling. We needed to update our tooling to make the game server executables available on Azure as well as AWS. And we sort of, again, intentionally decided not to update some internal tooling that still talked directly to S3 due to partially our lack of familiarity with those tools and the fact they were only consumed by internal teams, and we thought we could help them work around any issues that they happen to run into. And this helped keep us focused on our main objective of shifting most of our gameplay experience over to Azure. So 3 steps, 3 slides. How long could it possibly take? Well, you can see here that we started in about July of 2017, and we didn't finish until about July of 2019. So those 3 steps and 3 slides took us 2 years to finish. Now, as with any software project, we ran into some unforeseen challenges along the way. I think our challenges can be broken down into 2 basic buckets: human challenges and technical challenges. The biggest human challenge we have is what I call cloud migration is not fun. Folks don't join a game studio because they're really excited to migrate their infrastructure from one cloud to another. They join a game studio because they want to create fun experiences for their players. So we actually had a challenge finding developers willing to really dedicate themselves to this project. We overcame this challenge by essentially shifting personnel around until we got a good group of folks together that were all committed to really making this project their top priority. The end result of this is that this challenge was the single biggest drain on the whole project, and in my opinion, likely extended the required time to complete it by nearly a year. We had another technical challenge, which was the fact that while we were integrating with PlayFab multiplayer servers was still being built. It was a moving target. APIs were evolving and not everything existed when we needed it. Additionally, as with any new piece of software, bugs were prevalent and we would run into them regularly. So the solution for this was actually a technical challenge with a human solution. So we overcame this by working hard to establish trust between the Realms team, which just happened to be in Stockholm, Sweden, and the PlayFab team and myself, which just happened to be in Redmond, Washington. Building that trust really helped to make sure that both teams felt committed, and building the relationships helped make sure that any bugs that the Realms team encountered could be forwarded directly to the correct person on PlayFab quickly for the quickest possible resolution. So the overall result here was a bit mixed. While positive relationships were established between some members of the teams, but as new members of the team arrived on either side, not all of that goodwill was always inherited. So it was a little bit of an ongoing struggle. And then our last big technical challenge was a lack of existing automated tests. So the introduction of that abstraction that I mentioned earlier for which cloud to run sessions on actually involved a massive refactoring of code. And we didn't really have any automated tests to make sure that we didn't introduce regressions. To solve this problem, we had considered putting the whole migration process on hold, blanketing the service in tests, and then resuming the migration later. Ultimately, we decided that the pause of the migration would be too long, and so we decided to just really dedicate ourselves to writing tests for the new code as we went along. And the result here was a bit mixed as well. It was scary. We did introduce regressions, we did have outages, and we did have downtimes, and we did impact the player experience, which is certainly never our goal and was not desirable. Now, the overall result. Not only did we delete a whole lot of code that we used to have to maintain, but we also eliminated the burden of needing to worry about whether or not our infrastructure was going to be able to scale to meet our needs. Additionally, we had been spending a pretty fair amount of money on AWS, and now we've shifted that money to Azure, which just makes good business sense. And then the last one piece that I think is most relevant for this audience is that we provided a lot of early feedback to the PlayFab multiplayer servers team. We helped to make sure that the workflows that they were offering really worked for a large AAA title. We helped to validate that APIs were designed in a way that really worked for game developers. And we helped that team mature their own internal processes and understand how to manage the needs of a AAA title. Now, the hope is that all of that work we did and all of that pain we felt resulted in a better quality product for the PlayFab multiplayer servers team, which ultimately folks like you can leverage to make your game an even better experience as well. And then the very last thing I'll mention is that the relationships that we built between the Realms team and the PlayFab team during this project actually led to integrating other PlayFab features into Realms as well, such as processing payments for Realms on multiple platforms. So that was the big first part of the migration. I'm going to go ahead and turn it over to Mangal now to speak to migrating the Realms service itself. Mangal?
Thank you, Brian. Brian talked about moving the game servers from AWS to Azure, which was phase one of this project. I'm going to talk about the next phase of how we migrated Minecraft Realms service from AWS to Azure. Before we dive into that, I just want to give you a quick high-level overview of the service. Minecraft Realms service handles about 20,000 RPS of requests, and the data is spread over both relational databases and storage accounts. And our data comprises of a sizable amount of business critical data, including world state information, subscriptions metadata, and telemetry. And we had about 3 pre-production and 2 production environments, and up to 3 databases in each environment. So to give you an idea of the scale of our migration, we have 1 terabyte of data in the MySQL database and 60 VMs running our various services, and the inactive world data came to about 303 terabytes. So we divided the next phase into 3 major steps, namely database, compute, and world data migration. Breaking up the migration into such components allowed us to effectively move them independently and help completion in less than 5 months. First, we chose to move the databases. Our goal was to have minimal downtime during the migration and to reliably migrate over 1 TB of data distributed over the 13 databases. So, to achieve this goal, we enlisted the help of the Azure Fast Track team. This team has developed good patterns and solutions to enable seamless migration from other cloud providers or on prem to Azure. They helped us in unblocking and streamlining our deployment to Azure and saved us significant costs. For the database replication and migration, we leverage the Azure Database Migration Service tool. This tool simplifies the process of data and schema migration from different sources to Azure. Even though DMS supported schema migration as well, we just ran our database scripts in our code base to create the tables manually. Our MySQL servers are only reachable by our machines and not visible to the public internet. So we needed to set up a secure connection between our Azure DMS instances and both the source AWS Aurora DB instance and the target Azure MySQL database. So to achieve this connectivity, we created a site-to-site VPN between the Azure VNet hosting our DMS instance and the Aurora VPC hosting AWS VPC hosting our Aurora DBs. So after creating this VPN connection, we created a private link entry allowing us access to our MySQL server from within the Azure VNet. In the end, DMS worked great. And the other feature of DMS was it was free to use for the first 6 months. And since we finished our migration within 6 months, we didn't pay anything for using this tool. And we also initially suspected our replication to take significant time to move data from AWS to Azure via DMS. However, after our initial data load, replication was solid with less than 5 seconds of lag for our setup. Then we connected our AWS-hosted frontends to our database hosted in Azure. We chose this approach because we wanted a single source of truth for our data. Our next step was going to move our services to Azure as well. So we wanted to ensure that the front-end servers running both in AWS and Azure can connect to the same MySQL database in Azure. So having both the Azure and AWS instances sharing a single database allowed for instance switchover. And also we had correct data and we didn't have to worry about data integrity and things like that. So to do this, we created another site-to-site VPN that connected the VPCs hosting our AWS front-end instance to the VNet hosting the Azure MySQL database. All of this worked perfectly in our test environments where we didn't have that much traffic flowing between AWS and Azure. However, we hit some hiccups in prod due to VPN bandwidth issues. We chose the default VNet gateway SKU, and that was sufficient for our pre-production environment. However, the same SKU could not keep up with our production traffic. If we had picked the right VPN SKU, we probably would have been successful with zero downtime. So be sure to research and load test the VPN SKU size and choose the one that is appropriate for your needs. Now that we have moved our databases, the next step was to move our service, our compute infrastructure. So to ensure a seamless update for our players, we adopted a blue-green deployment strategy. We duplicated the infrastructure in Azure and pointed both the AWS and Aurora front-end servers to the same MySQL database in Azure. So we updated our test and dev clients to point to this Azure internal URLs, and this enabled us to validate our service. We made sure our services in AWS and Azure were functionally the same, and there were no errors communicating between the Azure services and the databases. This increased our confidence in swapping out the AWS EC2 instances with the Azure VMSs, and we had about 100% test coverage as well. So all that was left to do was to use DNS to cut over traffic from AWS to Azure. We still had the AWS instances running for a little while in case we encountered issues and had to roll back. So it's really important that you have a good rollback strategy. If things don't go well, you should be able to quickly revert. The trade-off in this approach that we chose was we had to duplicate our infrastructure in Azure for both our databases and our services, and this led to increased costs. And also, in order to maintain the services in both clouds in parallel, we had to write some code within our service to recognize the current cloud that it was hosted within. And also, we had to write deployment scripts to deploy to both cloud providers at the same time. However, some of the code refactoring was inevitable as we had to do that for supporting our service in Azure anyways. For the duration of our test, we were paying for both AWS-hosted instances as well as instance hosted in Azure. This increased our costs significantly, but was instrumental in decreasing our downtime. So decide based on what the deployment or migration strategy that you choose, just be prepared for increased costs. Now that we have moved our database and compute infrastructure, our service was up and running in Azure. And all that we were left to do was move the inactive world data. So we planned the whole migration with minimal impact to gameplay. And as Brian mentioned earlier, active realms were moved when players first access their realm after the migration to PlayFab. So this worked out really well because active players were already moved, and all we had to do was move inactive worlds. So since the active worlds were already moved, you might be wondering how much data there could be to move. As it turns out, like a game like Minecraft that has been around for a while with players building amazing and complex worlds, these files could get really large. We had about 303 terabyte of inactive world data left over in AWS, spanning over 13 million files. Our terms of service didn't allow us to arbitrarily delete customer data, even if they weren't accessed in a long time. We are working on updating our retention policy. However, it wasn't an option available for us at that point of time. We used AZ Copy to move the data from AWS to Azure. AZ Copy is a Microsoft tool that, amongst other options, also supports copying from AWS S3 buckets to Azure Blob Storage. We ran AZ Copy in parallel on a bunch of VMs, about 8 or 9, and it took us about a week to copy the data from AWS to Azure. And then we ran a database script to update the location of the world data from pointing to AWS S3 bucket to the Azure Blob Storage equivalent. Initially, our plan was to delete the S3 buckets right away, but we weren't sure that there might be some code accessing this data, so we just left them for a while. We just cleared the buckets and left them for a while, and then eventually deleted the S3 buckets as well. So we walked out of this migration with a bunch of battle scars. There are some things that worked really well, and some mistakes were made along the way as well. So our DB migration failed twice. Our assumption that the version of MySQL 5.6 and AWS Aurora 5.6 was performance-wise being the same was a miss. We found that MySQL 5.6 in Azure had some significant performance issues, and we also hit a bug in Azure MySQL 5.6, which is since fixed. We learned the hard way that 5.7 had significant performance upgrades and enhancements over 5.6, and we had to upgrade to MySQL 5.7. Upgrading to 5.7 was a significant undertaking as well. We had to first do it on the AWS side to make sure our services work with this version, and then we had to do the same in Azure as well. But switching to 5.7 would have avoided some downtime. So we strongly encourage anyone doing a similar migration to investigate switching to at least Azure MySQL 5.7. So we also hit a roadblock because of the VPN's queue size. There were fundamental differences between how AWS and Azure handles site-to-site VPN. So load testing prior to our final production migration would have identified these performance issues. So please be sure to load test with your production load before the migration. And moving data wasn't easy either. It took us a week of running AZ copy over 9 VMs. And also we had to duplicate data in both AWS and Azure, and that doubled the storage costs, and deleting the S3 buckets took significant time as well. what went well. So our greatest or silver bullet in solving this migration was the Azure Fast Track team. Their support and guidance was critical in making this move a success. They were really invaluable during our migration. So if you haven't already, we highly recommend engaging this team. Azure DMS was amazing as well. The replication was smooth, and the cost is like it's free. So what could be better? Upgrading to 5.7 improved our performance, greatly improved our performance, and we were able to even bring down our SKU size couple of tiers. So yeah, definitely use 5.7 if you are migrating. And AZ copy just worked even when we were copying like ridiculous large amount of files. The tool itself was great, and it just worked well. So, what are some of the lessons we learned? Be prepared for increased costs during your migration period. Keep in mind that data duplication across cloud providers can effectively double the storage cost for the span of the migration. Also, ingress and egress charges on each cloud provider adds up. And you'll most certainly have to make some code changes. There might be some places in your code like there'll be knowledge of the cloud provider that it's hosted in. So be prepared for that as well. And even with a successful blue-green deployment, you'll need a few minutes to finish replication and shut down the replication link before you can fully cut over to the new cloud provider. So for that reason, we would recommend putting your service in some kind of read-only mode if possible prior to flipping the migration switch. And migration also takes a long time. We took about 6 months to migrate our service, our compute infrastructure, and the world data. So be prepared for the time and the cost that it takes for migrating your infrastructure. As with any project of this scale, things did not always go according to plan, and some mistakes were made along the way. But if we can do it, you can do it too. No one on our team had any experience moving cloud providers before we started. And as Brian said, no one joins a game studio wanting to move cloud providers. They want to do cool and fun stuff. It was a little bit tough, and it took a while, but it's very much doable. And you have all these additional resources to help you with the Azure Fast Track team and all the cool Azure resources. And we also wrote a series of blog posts recording our migration journey. So please be sure to check them out as well. We shared our migration journey with you in the hope that you can avoid the mistakes that we made. So also, Azure, for more information on PlayFab and Azure, be sure to check out ID at Azure, which is launching this summer. Thank you for listening to the challenges we faced and the lessons we learned while moving Minecraft realms from AWS to Azure. Enjoy GDC.
Thank you for joining us today. Enjoy GDC.